In this video, we are going to learn about parabolas at the origin. Specifically, we're going to learn about how to tell if they open up, down, left, or right, and how to graph them. And I should add, we're going to graph them without making a table of values. It's going to be very quick. So please remember that whenever you first learned about parabolas, you probably learned y equals x squared, and they showed you what that looked like. And it looked something like this. Alright, so that's y equals x squared. And we saw that if we made it negative x squared, then it was going to look like this. So that turned it upside down. Alright, now, so just I want you to hold that in the front of your mind. That's what it looks like when we have y equals x squared. Now, please understand that in the models we're going to be doing today, we're going to be looking at the equation written around in the other direction, more like x squared equals y. But that's still the same thing, okay? It's still the same thing. Now, if you ever see an equation that has the y squared instead of this normal x squared like we're used to. If you see one that has y squared equals x, alright, how would we even put this in the calculator? You know what I mean? If you go to enter an equation, it already has y equals, and so you could put in x squared. But if you saw y squared, how would you even put this in the calculator? If you see something weird like this, that means it's sideways. Alright, it's either leftward facing or rightward facing. Okay? So, when you look at problem number 1 here, is this going to be a normal up or down parabola, or is this going to be a strange sideways facing parabola? Yeah, this is a strange sideways facing parabola. Again, the parabolas that we're used to always were like this, y equals x squared. So even if I write it in this new way of writing x squared equals y, I know that it's normal for us to have the x squared. So when I see the y squared, I know something strange is happening. So this is definitely going to be a sideways parabola. So it's either going to be a leftward facing or a rightward facing. Notice how everything is positive. So that means we're going to be going in the positive direction. And for x values, that is to the right. So this one is going to be headed to the right. Okay, how about number 2? Reading it from right to left, I see y equals x squared. You know, I'm ignoring the 8 for right now. Y equals x squared. Well, that's our normal parabola, and so I know it will either be up or down. And because everything is positive, I know it's going to be up. Alright, looking at number 3. Reading it from right to left, I have x equals y squared. No, that's strange. It shouldn't be y equals x squared. So this must be one of those strange either left or right facing sideways parabolas. Because it's negative, I know it's going to be going in the negative direction, which if we're going left, right, left is the negative direction. So this will be a left-facing parabola. And for number 4, this is the normal y equals x squared that we're used to. So I know it's either going to be up or down. Because it's negative, I know it's going to be down. Alright, it's time to graph some equations that are in this form. We're going to graph them and identify the focus and the directrix of the parabola. Alright, so that's 2 new vocabulary words I just slipped in, focus and directrix. The focus is the point that's on the interior of the parabola. It's sort of like the parabola is wrapped around the focus. What it is the focus is the point where if you measured the distance from the focus to the parabola and then an equal distance from the parabola to this line called the directrix, those 2 distances would be the same. For example, this distance is p and this distance is also p. But it doesn't have to just be vertical like that. If I measured, for example, this distance right here, all right, from the focus to this point. And if I measured this distance from this point straight down to the directrix, all right, those two distances would be the same. All right, in this case, 5. All right, if this would turn out to be 5, and if I did the distance formula right here, this would also turn out to be 5. So that's what the focus is, those distances, the focus and the directrix. If you pick any point on the parabola, the distance to the focus and the distance to the directrix will be the same. And I might as well mention this now because it is about to come up. There's something called the focal width, and that's the width of the parabola at the level of the focus. So the distance from here to here is going to be the focal width. And it turns out that if we call this distance from the focus to the vertex P, then the focal width is always going to be 4 times P. For example, you'll notice that in this picture the distance P is 4, so that means the focal width should be 4 times 4, which would be 16. And sure enough, if you look here, this position is 8 to the left, this is 8 to the right. That is in fact a total of 16. So the focal width here is 16. So just something to keep in mind. Alright, our model for an up or down parabola with vertex at the origin is going to look like this. X squared equals 4p y. Okay, now if it was one of those strange sideways parabolas, then that would look like this. Y squared equals 4p x. Yeah, you see the wrong variable is squared, you know that's going to be sideways. Anyway, back to the normal ones. So an example of this would be like if you had, say if you had x squared equals 12y. Alright, so here the 12 is the 4p. And the point of that is we can use this model to help us know what p is. In other words, if you look right here, the 4p and the 12 are the same thing. That means 4p must equal 12. So if we go ahead and divide by 4 on both sides, that tells us that p is 3. Okay, so look at number 5. Is this parabola going to be facing up, down, left, or right? Go ahead and answer out loud. Alright, hopefully you answered that it will be going to the right. We see that the y is squared very strangely, so we know that this is going to be one of those sideways parabolas. And because everything is positive, we know that this is going to be facing to the right. Okay, so don't draw this yet the way I am. I just need to illustrate what you should be thinking. So you know the parabola is going to be doing something like this, alright, facing to the right, like we just said. Don't draw it yet, it's too soon. Now, we need to know what P is. So we know, like we said a moment ago, the model is like this. Y squared is equal to 4p times x. Okay? So that means we know that the 4p is 8. So off to the side somewhere you go, okay, 4p is equal to 8. So if you divide both sides by 4, then you quickly realize that p is 2. Alright, now the benefit of that is that tells us where the focus goes. So if p is 2, that means the focus is going to be here. Alright, that's why it's so important that we decide immediately, first thing, which direction the parabola is going, up, down, left, or right. Because if the parabola was going up, then we would have put the focus up. But since it's going to the right, that's how we know to put it here, to the right. Okay? So fine, we know that's going to the right. So if the focus is here on the right, that means the directrix will be the equal distance over here to the left. So it'll be a vertical line over here. Okay, so there you go. Now let's draw the parabola a little bit better by thinking about the focal width. Now here's the vertex, of course, is at 0, 0. But let's talk about the focal width. The focal width, alright, the FW, if you will, we know that that's always going to be the 4p. Alright, now I don't need to multiply 4 times 2 and get 8. I can just recognize that the focal width is this number right here. Alright, it's already 4p. We don't have to create it. So the focal width is 8. Okay, just focus on that. See what I did there? So if the focal width is 8, that means from the focus I can go up 4 and down 4 for a total of 8 across. And these 3 points are enough for me to draw a rough sketch of this parabola. So there you go, we sketched the graph. Now the focus is this point 2, 0. So let's make that happen. The directrix is this vertical line at -2. So vertical lines are always x equals something. So x equals -2. Y equals -2 would be a horizontal line. And I guess that's all they really asked us for. Alright, let's do a few more examples. First of all, decide if this parabola is facing up, down, left, or right. Go ahead and answer out loud. Hopefully you said down just now. Ignoring the -12 for a minute, we have y equals x squared. That sounds like a normal parabola to me, so I know it will either be up or down. Because of the negative, it's going to be facing down. Okay, so when the x is squared, I know it will either be up or down, because that's normal. Now, we need to next find out what p is. Well, see this -12 right here? So 4p is going to equal -12. So dividing both sides by 4, okay, that's going to give me p is equal to -3. Now I know that it's going to be down, so that means this is going to tell me where the focus is. Now first of all, the vertex is here at 0, 0, and again I know that because there's nothing being added or subtracted. You know, if it was like x plus 2 squared equals -12 times y minus 3, then the vertex would be, let's see, vertex, this fictitious vertex would be -2, +3, opposite of this and opposite of that. But in the absence of anything being added or subtracted, then it must be 0, 0. So if the parabola is down, the focus must be down 3. So that will put the focus right here. That means the directrix, by the way, must be up here. All I need is the focal width in order to finish off the sketch. The focal width is going to come from right here. Focal width is always positive, so ignore the negative sign. The focal width is 12. So looking at the focus, if I want a total of 12, that means go to the right 6 and go to the left 6. So that means I can draw my parabola through here. So there's my sketch. Now the focus is the point 0, -3 here. So 0, -3. And of course the directrix is this horizontal line. This is y equals 3. Y equals 3. Alright, so that's it for number 6. Let's do 2 more examples. Is this parabola facing up, down, left, or right? Let's see. I have x equals y squared. That's strange. This must be one of those sideways parabolas. And since it's negative, it's facing to the left. Next, I need to know what p is. See that -16? Well, 4p must equal the -16. So dividing both sides by 4, I come up with P is equal to -4. Now, together with the word left, this tells me where the focus is going to be. Now, remember, our vertex is starting out at 0, 0 today, because these parabolas, nothing is being added or subtracted, so you know it's going to be 0, 0. So the focus will be to the left of this. So 1, 2, 3, 4. So here's the focus. Now that means the directrix must be 4 to the right, so it must be a vertical line over here. Now if I had the focal width, I could put down a couple more points. Well, the focal width is going to come from this number right here, 16. Focal width is always positive. So if I need 16, starting from the focus, I know I need to go up 8 and down 8 for a total of 16. This gives me enough points to draw a rough sketch. So there is our rough sketch. Now the focus is the point -4, 0. The directrix is a vertical line, so vertical lines are always x equals. In this case, x equals 4. Okay, so that was it for number 7. Let's do one more example. So looking at number 8, is this going to be up, down, left, or right? Well, let's see. Y equals x squared. That's normal, alright? Y equals x squared. And everything is positive, so that's going to be an upward facing graph. So this will be up. Okay? Now, in this new way of writing the model, what we have these days is we always have the squared variable first. So let's go ahead and write this in the new way, where we start off with the squared variable. So I'll have x squared is equal to 2y, like that. Now we need to find the p-value, and but this 2 right here is 4p. So this is kind of interesting. So 4p must equal this 2. So if I want to find the p-value, you know I'm going to divide both sides by 4. So that's strangely going to give me p is equal to 1/2 once you reduce this. So that's a very small p. But yet that's what it is. So we're going to have to deal with that. So this is going to tell us where the focus goes. So it's going to be half of a square up. So I think I should zoom in. Now our vertex, of course, is still at 0, 0. With p being 1/2, that means the focus is going to be half a square up. Alright, so it's very close. That means the directrix is going to be half a square down. So it's going to be a horizontal line right here. Now let's use the focal width to place a couple more points so we can draw the sketch. Now this number is the focal width. So the focal width is going to be 2. Alright, that's a total of 2 across. That means 1 to the right, at the height of the focus, and 1 to the left. So this is a tight little grouping, but we're going to go ahead and use it anyway. So your sketch would look something like that. Now the focus is this point right here, which is the point 0, 1/2. And the directrix is right here. It's horizontal, so that's going to be y equals something, y equals -1/2. And that is it for this video. Alright, we will continue working with parabolas on the next video.